So okay guys, let us take one more question. How to find its voltage gain, input impedance, output impedance directly without drawing any model. Already I explained one question guys, and this is the question number 1. So you can watch previous class also. This is part 2 and you can watch previous part 1 first. Okay, so again same thing guys, same thing. While doing amplifier analysis or AC analysis or small signal analysis, all the DC sources are connected to ground, all the capacitors are short circuited. Now you can see here in this circuit there is a no bypass capacitor. So here we are finding voltage gain without bypass capacitor. So again all the DC sources are connected to ground, all the DC sources are connected to ground, all the capacitor act as a short circuit under this small signal condition or amplifier analysis or midband gain analysis. Again we have to mark resistor present between base and emitter. Okay, this is small re, dynamic resistance, because here base and emitter diode is there which act as a small signal resistance under this small signal condition through which emitter current is flowing. And here also guys emitter current is flowing. You can watch my previous classes guys. Okay, you can watch my previous classes. So here between base and emitter you have to mark small re through which emitter current is flowing. Here also emitter current, this is your base current IB. Okay, and this is nothing but GMVB or beta IB also you can mark. Okay, so here I am using GM into VBE guys, GM into VBE. Okay, and here this is the drop across this terminal is nothing but VBE, like this is the base voltage and this is the emitter voltage. Okay, now important observation here, this base voltage, this is nothing but simply V in guys. Okay, so here base voltage we can say this is V in. Okay, this is V in. Now you can see emitter is not connected to ground, but you can observe what is the relation between small r and capital RE. So through small re emitter current is flowing, through capital RE also emitter current is flowing. So in two resistors same current is flowing. Here same current is flowing through two resistors. So that's why we can say small re and capital RE both are connected in series because same current. Okay, so both are connected in series. Here input, here voltage V in, this is 0 volt. Both the resistors are connected in series, and VBE is nothing but potential drop across this small RE. So both series, and we want to find voltage across this resistor. So simply voltage divider we can use. So using voltage divider, VBE is equal to small re upon small re plus capital RE into V in. That's it. Correct? Directly you can do. Now here again this RC and RL both are in parallel. You can see guys, simple network theory concept. So here low resistance and RC both connected in parallel through which GMVB current is flowing. Here same GMVB from ground to V0 node. So what is the output voltage? In this case again output voltage, it is flowing from ground, that's why we can take negative. So minus GM VBE into RC parallel RL. Now what about VBE? So VBE we got, VBE is equal to small re upon small re plus capital RE into V in. So you can replace VB with this value. So output voltage V0 equal to minus GM into RC parallel RL into extra term will come into picture. So you can see guys, without bypass capacitor there is a decrement in the voltage gain. Okay, so this is the new voltage gain without bypass capacitor. Without bypass capacitor voltage gain is, now you can see this is small re upon small re plus capital RE. Now small re will be in ohm and this capital RE emitter resistor will be in kilo ohm. There is a significant reduction in the voltage gain guys. Okay, so in this way directly you can get the correct answer. Now same thing guys, we can find the input impedance also guys, input impedance also. So see how to find the input impedance. So simply remove this thing. Now I am finding input impedance. Now again see, now both the resistors are connected in series, so total resistor will be small re plus capital RE. And if we see the resistor, from the base side, so total resistor is small re plus capital RE, and the resistance seen from the base side simply you have to multiply with beta plus 1. So beta plus 1, Now the total resistor is small re plus capital R because there is a no bypass capacitor. Then there is a no bypass capacitor. So small re plus capital R, and if you seen from this input side, the resistance seen from the input side, then RB will come in parallel with this resistance, correct? See, this is between base and ground, this resistance. Now here one more resistor RB is there. So finally the resistance seen from the input side is RB parallel beta plus 1 into small re plus capital Re. So there is increment in the input resistance without bypass capacitor. There is a decrement in the voltage gain. Okay, voltage gain is reduced, okay, significantly. Now there is a no change in output impedance because once input is 0 volt, then this current will be 0 because here 0 volt, here 0 volt. So emitter current 0, that's why this collector current 0. Okay, collector current 0, that means output impedance RC. So without bypass capacitor, overall voltage gain is reduced and input impedance is increased compared to previous question. Okay, and there is a no change in output impedance. So that's why here we can say gain is reduced. So that's why we can say here emitter provides negative feedback. It is known as emitter degeneration or degenerative resistor. Okay, so remember this direct method to calculate voltage gain, input impedance and output impedance. Here in this method need not require to draw any model. Without drawing RE model or T model or beta RE model or R pi model or H model, you can solve any question. Okay, so this is important method that you have to remember. Okay, thank you guys.